All right, we're back for another one. This is where the rubber is going to hit the road. I hinted at this in the last video, but what we've done so far has been kind of living life on easy mode because this Oxygen meta library that I've written is for specific cases of deriving type classes which fit into the category of this K0, like your basic JSON decoder, JSON encoder, all those examples that we did. Um, Life is very easy for doing those. The helpers are very nice. I think kind of hit the nail on, not to pat myself on the back, but I think I kind of hit the nail on the head on that one as far as um, it makes it very easy to derive type classes using macros. Um, that being said, if we want to do something a little more complicated, like this transformer here, which we'd like to transform a simple like A to B function essentially. Um, like we as programmers we have these domain models and API models and DB models and all this stuff that's just annoying to write. Um, so this will let us map that easier. We should essentially be able to do something like domain models dot user dot transform to API models dot user. That's what we'd like to be able to do, something like that. Okay, so there's the context of what we're trying to do, just a simple transform here. But we're going to get exposed to a lot more of the low-level stuff going on with macros because we don't have all of those nice helpers with nice type functions, which those those child functions that we used, where there's the type and it just gives you the type in the function. That's just a nice helper because we're going to see here we're going to have to deal with a lot of stuff that's any. And on that note, uh, the reason I personally like macros so much is because I feel like using like the inline def and mirror approach, I've been screwed a bunch of times because you end up having to do these as instance ofs, and if the compiler doesn't figure it out, it kind of just will do it at runtime. And that's really frustrating for me because you just lose a lot of control over the code you're generating. But with macros, if you okay, here's the good metric of if you should be using an as instance of in the outputted code. You should not be using as instance of in the outputted code unless you would be using as instance of if you had written that type class or whatever macro you're doing by hand. Um, you might have to do some as instance ofs or more like an as expert of behind the scenes in the macro, but that's all stuff that if you botch that, the macro is going to fail to compile code. You're not going to ever get an as instance of at runtime doing that sort of stuff. So we'll get into seeing what that looks like, but just a heads up that we're going to be diving into the weeds on this one. Okay, so let's get into it. I've already laid out some stuff here. I've given us some like I don't know, just some simple instances to play with. This seek transformer of this will let us do this guy where we have like a seek of note and a list of note, and so it figures out the fact that they're both sequences. Nice little helper from Oxygen Core. Shameless plug. Okay, let's get to it. So, like I said, we've laid out a lot of the groundwork here. We have our entry point to the macro, this inline def derived, which needs to take two type parameters as opposed to one. And then we need to do, this is the macro that we're actually calling. And so now we have this from and to, which we need the types in order to work with these things. And we're going to export or return an expression of transformer, and then this splices that down into a non-expression here. Okay, so I've created a separate file because this is definitely not my first time trying this, and I think it's going to be easier if we split it out. So let's get to it. So what we're going to want to have here is a way to do, we're going to need to represent this zipped nature, because we're going to be able to reuse a lot of the stuff, or at least some of the stuff, from product generic, but we're not going to be able to use it verbatim. So we're going to have to write our own little helper functions for the fact that we're working with really two product generics. And you could do it for some types, but for now we're going to not do that. And we can maybe do that later. The video gets a bunch of likes. We'll do something. How about that? That's what YouTubers are supposed to say. Anyway, so we're going to do zip fields from 2. Okay. And so we're going to have a from generic, which is going to be product generic of from. Very nice and easy. Just like that. What the heck am I doing? Typing all the wrong stuff over here. Okay, there we go. We got our generics. And now, if you see in this example here, we're trying to go from the domain model to the API model, right? And so with this little example that I've plugged in, this note has more fields. For some reason, the API model doesn't care about ID. And so if we're going from the domain model to the API model, then we don't really care about the ID, and so we're not going to require or force you to have it be one-to-one, right? As long as the from is a superset of 2, we should be fine, right? So how are we going to do this? We will create a from field map, which is going to be map of string to from generic.field. And we have our first example here of these wildcard types, because really a field could be anything. So what we're going to do is from generic fields, and we're going to return from field dot name from field. And give it a map. Okay, so now we can get a from field by the name. And so then we can create a zipped fields, which is going to be this contiguous, I haven't created this up here, but we're going to need a from generic to generic. And I know there's all sorts of nice stuff that lets you put that in the same parameter group now, but IntelliJ can't figure that out, and I don't want to make my life hard. So we're going to do it like this. Contiguous, and we're going to do a from generic field. Got more wildcard types to work with here, so it's going to be what it is, and we'll create a nice little helper to work with it. Okay. Okay, so here we're going to have, let's just do it like this. So we're going to do zipped fields from 2. Awesome. And then what are we going to do here? We're going to do 2 fields, 2 generic, and we're going to map these. These are also contiguous of fields. Fields dot map. Okay, there we go. 2 field, and you see here we've got these untyped things, but we don't really care about the types yet. We're just going to zip them. So all we care about really is the name. So here's 2 field, and then we're going to do from field map or else. And what do we want? We want 2 field that name. And if not, we're just going to error. Okay, what are we going to error? I'm going to say won't be able to populate to field in code. Because from okay, so that should be, what are we looking at here? Funker. Awesome. You can see, come on ID, cooperate with me please. All right, well, for some reason I can't make this bigger. That's really stupid. Oh, there it is. Okay, awesome. Okay, so this is all not failing, but then if we do something like this, oh, we haven't called it, that's why. Okay. Fields, 1, 2, goes zip field of 2. Now we get this error, and we get it right here, but that doesn't really give us as much context as we could really have here. So what we can do is we can actually emit this error right on the 2 field. Now if we do this, it points right here, hey, this is the field that we can't do. Very cool. Okay. So let's fix that. All right. We're back to compiling here. I'm not going to mess with this. It's going to get stuck again. Okay. Cool. So what does that mean? Now we have these zip fields. And so let's create ourselves a little function for this. So this is similar to like what we had in oxygen meta, where it gives us these type or these, oh, I can't remember the name of it. The function where the type is defined within the function, like this. I'm just gonna do it like that. Okay. And so what this is going to do now is these are types that we're kind of just making up. We're giving a name to, and so we're going to need actual types for them. And with that, then we're also going to need fields of that type. So this is going to be from generic.field of from, and then a to generic.field of to. And it's going to go to out, and then we'll get a contiguous of out. Okay. And so it's essentially like doing a map here, except we have nice types to work with, and we have these type instances, which are very important when you're working with types. So the method that we're going to use to do this is we're just going to do zips.map. And if we do this, you see these are no good. We got the wildcard type going on. So what we can do to erase that is we can go like this. These are not types that really even exist. This is, I don't know if this is the pattern you're supposed to use. I saw it somewhere. But it makes it very nice that you kind of just create this unlabeled type that doesn't really mean anything other than the fact that you can uh, type your give types to things that might not otherwise have one, or the type really only exists as you've found it from somewhere, so you don't have a name to give it. This allows you to give it a name. So the way you do that then is you can do from field, which is a from generic field from. And so if we try to do just this, compiler's not going to like that. See, these are untyped. And so this is where we kind of get to be a little naughty, and we get to do this typed as helper, which is essentially an as instance. And this isn't actually doing any as instance ofs on your underlying types or any code that you're generating. All it's doing is doing an as instance of on the type of your field so that you can give a nice type name to it. Okay, and so now we should be all happy. Yep, just unused stuff. Awesome. So now what we can do is just call our function here. See how this type of our field has a type to it, and so what we've done is by changing the type of our field, we've changed the underlying type to point at this type, and so now that's how we make this all work. Hopefully it makes sense. Leave some questions if it's not making sense. To field and missing parameters for none. Oh, we want that to be, there we go. Okay, cool. So now we have the ability to do this map too. And so it's going to let us map using types that we've defined. Cool. So now how to do this? This is where it's going to get fun. So what we need to do is we need to be able to, we have an expr of from, and we need an expr of to, which basically means we need to take things from and instantiate a to. So if we do, there's these nice nice instantiate function here that we used in a previous video, where you can do like for ID either whatever. I don't think we're going to use that. I think we're going to use this lower level one, which is the fields to instance, which is basically just a bunch of expressions that are kind of untyped, and then it checks under the hood to make sure they're the right type. So let's do that. What are we going to do? I guess let's just go for it. All right, so here we need to create just a bunch of expressions, right? And so if we do our zips.map2, here we're going to have a from and a to, and then we actually can just leave those blank. We don't need to give them names. They're just implicitly there for us to have types. And then we can do from field is going to be zips.from generic field from. I'm going to rename these. Arbitrarily naming everything, why not? Let's see if I can. Cool. Cool. All right. So what? How far have we made it? So we can see here that we're instantiating we're instantiating these API models, and we basically have just populated all the fields with question marks because that's the expression that we gave it. Um, so we got to actually transform it. So how are we gonna do that? So all right, we're gonna need a transformer for each field. So how's that gonna look to do that? It's gonna be an expression of a transformer, not an actual transformer. It's gonna be from to. And we can do this with, I think it's called summon. Yep, expression summon. This one, for some reason, never likes to show the return type properly, but it's going to be get or else. Tightening everything for me. And we'll put this again on the to field position. Okay. I got some warnings, but we got rid of those. Okay. So here, so we'll say no given instance of you'll notice that we're able to do this type repper. What the heck? Okay, we're able to do this type repper, which requires. Oh my god, is it just gonna totally wowza? Okay, it really doesn't like us. So I wonder if this will fix it. Not really. Okay, who knows? IntelliJ does decide to be very stupid when it comes to macros a lot of the time. Okay, so we know from here it's compiled. So now we have this expression of transformer. So we should also be able to do um, we should also be able to get an expr of this from, which from the way we can do that is we have our field from field from parent, so that requires an expr of uppercase from. We see here we have an expr of uppercase from, and it returns an expr of lowercase from. Awesome. So that should also work. Cool. So now we have the from, or the field, the specific field. We have the transformer for the specific field, and now we just need to call it. So transformer. We call that transform from field expression. Awesome. Is it really that easy? Let's see. All right, I've gone ahead and skipped ahead here because I had to type up a bunch of stuff. But what I've done is I've added a nice, pretty toString to our API model, and we just have the default toString for our domain model so that we could tell them apart more easily. And I've made this a vector and this a list, just so that's a little bit more different, because I think it was like list and seek, and list is a subtype of seek, so they're very different now. Yes, so what we are going to do is run it. So this is our example, and we'll see. Awesome. So here we can see that we have our domain model, and then here we have our API model, and the only thing that has done that transformation is our little transformer that we just derived. So, ta-da! I'm going to leave it there today. If you guys have any ideas of something you'd like to see further extended on this transformer idea, or if there's other macro ideas that you all have that you'd like to see an example of, I also just wrote like a boatload of SQL macros to let you I just basically wrote an ORM, and I had to do a lot of macros for that, so I could highlight some of that stuff. I could highlight just the SQL library in general if y'all are interested in that. Let me know. Let me know what you're interested in. I'm doing this to teach you guys. So have a good one.